or rather the substitution reaction. The reason we did addition and substitution reactions together, even though they both start with different things, is because, that is to say, addition starts with an alkene, substitution starts with an alkane, is that there's a particular experiment that you would have done in class called, oh, that's about, there's a particular reaction called the Bromine Water test. And that's used to distinguish between an alkane and an alkene. You would have used cyclohexane and cyclohexene. The reason you would have used those is because unlike ethene and ethane, which we've been talking about, they're gases, ethane and ethene. Cyclohexane and cyclohexene are both liquids at room temperature. And the idea is that you don't know which one you've got. You've got a liquid and you don't know whether it's an alkene or an alkane. How are you going to figure it out? Well, the trick is that you add bromine water, which is substance with Br2 in it, and you add that to this unknown hydrocarbon to see whether it's an alkane or an alkene. Now, if it's an alkene with its double bond, this is going to undergo an addition reaction, and the way that you'll know that is that very, very quickly the bromine water will be discolored, or rather it goes from having a brown color to being clear. The bromine water will lose its color, rather than be discolored. Now that's because this double bond readily reacts with the bromine and incorporates it straight in without any problems, and creates I don't know, dicyclobromine thing. Now, if it's an alkane though, if it's cyclohexane, well, then it's not going to readily react. It's only going to very slowly, because it's undergoing instead a substitution reaction. It's only going to very slowly change the color of this, and only in the presence of UV light. So by looking at it just as soon as you put in the bromine water, you can immediately see whether it's a hexene or a hexane, or an alkane or an alkene. Now you can confirm. So obviously, if it takes away the brown color immediately, you know that it's an alkene, and if it doesn't, then you know that it's not an alkene. But if you wait a while and it starts to take it away very slowly in the presence of UV light, well, then you can say, well, it must be an alkane, because you can say, well, it didn't undergo the addition reaction, but it is undergoing a substitution reaction, therefore it's an alkane. So that's the bromine water test, and that one kind of ties together the concept of substitution and addition reactions. And the final kind of reaction that we're going to look at is another form of addition reaction, but a very special one, polymerization. Now, just some definitions here. A polymer is a very, very long molecule composed of many monomers. That is to say, it's got repeating units. And a monomer is a single unit that gets turned into a polymer. The point is that a polymer is essentially a bunch of modules that are identical, joined together thousands and thousands of times. And our ability to use a simple component, a simple module that we can then add together, allows us to make very, very long molecules. And very long molecules can have very particular chemical properties, which we find useful. And when we're talking about polymerization in hydrocarbons, we're talking about plastics, and that's very important to remember. This is about manufacture of plastics. Hydrocarbon polymers are plastics. Now, the first one and the main one that we're going to look at is the polymerization of ethene. So same molecule again, also known as ethylene. And ethene is a monomer, and it can be polymerized into a polymer. And when we polymerize ethene or ethylene, same thing, we turn it into polyethylene, which is thousands and thousands of this unit combined together. And when we do combine it together, we basically get this. And the way that we do it, and what makes it such a good candidate for turning into a polymer, is this double bond. That's highly reactive, and by breaking it, we make it into a ready-made kind of joining machine, and we can get it to join itself under the right conditions. And you need to know what those right conditions are and what we do in industrial processes to make it happen. So let's get into that. Thing you need to know in a polymerization process is that consists of 3 stages. First of all, initiation. And what happens here is that one of the molecules, basically to make this happen, we need a free radical catalyst that's involved in the reaction. So under the right conditions, which is a lot of heat, pressure, and the free radical catalyst, one of the monomers joins with this free radical, which we're going to call R, and that basically primes the molecule for further reaction. So this is a very temporary state, and as you can see, it's because it breaks this double bond, it joins with the free radical, and it's got a free bond still, so it's a very reactive molecule. And because it's a very reactive molecule, what this free radical does is it basically it initiates it, and it turns this into the beginning of a chain of molecules, because the next thing the free radical does, and this is the propagation step. Step 2 is propagation. What it does is it brings in another one of these. So the free radical brings in another one, and then it swaps itself out of the whole equation. Or rather, basically it attracts in a molecule and then jumps onto the other end. So the free radical doesn't just get out at this stage like it would with a very simple kind of catalyzation. It would bring in a molecule and then eliminate itself. Instead, what it does is it brings in a molecule, but then it jumps onto the other end and it keeps going. So it helps to create a chain, and propagation is that process many, many times, and the chain grows and gets longer and longer, and you get more and more of these units. And then the final stage is termination, which is where we end the process and we end the conditions that make the polymer, and we do that, of course, when the polymer is very, very long and, well, the right length for what we want to do. Alright, there's heaps of information on the net that should help you with the rest of this topic. Basically, there's a few things you need to know about polymers, and you can get a bit more information about this out there. There's 3 polymers you need to know about. They are polyethylene, polyvinyl chloride, and polystyrene. You'll need to know about the production of one, so just know the production of polyethylene, but you'll need to know, you need to be able to recognize polyvinyl chloride and polystyrene. I'll draw them for you now. Polyvinyl chloride begins with vinyl chloride, which is just an ethene molecule with chlorine instead of a hydrogen, and predictably that makes a polymer like so. So these brackets mean that that's one unit, and it's repeated. This unit is repeated thousands of times. So that's polyvinyl chloride, also known as PVC. And polystyrene is a bit more complicated. Still, it's got this double bond, so all of these are addition polymers. They've got the same chemical kind of reaction going on when they're formed. But this one's got a whole little carbon ring down here. It's a C6H5. That's a benzene ring. So polystyrene is actually also known as vinyl benzene or ethynyl benzene. Benzene. Alright. And yeah, it once again just goes through an addition reaction to form its final polymer. So instead of a chlorine down here, you've just got that same C6H5, and once again that's repeated. That's the time. If I ever draw a bond, by the way, that doesn't have anything on the end of it, that implies there is a hydrogen on it. It's not specified, then it's a hydrogen. Alright, so that's production of materials 1.1. I hope that's been helpful.